Hello everyone, thank you for watching Edupedia World videos. So now in this part 5 video of daily monitoring, we are going to see a couple of transactions which are related to RFC, remote function calls monitoring. Now transactional remote function calls, TRFCs. Data can be transferred between two SAP systems reliably and safely using a transactional RFC. So we have different SAP systems. Now we want data transfer to be happen between those two systems. So a transactional RFC is a reliable and it's a safe way through which data can be moved from one system to another. The called function module is executed exactly once in the RFC server system. The remote system need not be available at the time when the RFC client program is executing a TRFC. The TRFC component stores the called RFC function together with the corresponding data in the database of the SAP system, including a unique transaction identifier, that is TID. Now, here what happens is a function module, this TRFC is called from the server system, that is the source, and here the remote system need not be available when the RFC, the client program, is executing a TRFC. So here the TRFC is stored, and once the target system is available, then it is shipped. So here the TRFC is identified by a unique, it has a TID number, transaction ID. If a call is sent and the receiving system is down, the call remains in the local queue until a later time. The calling dialog program can proceed without waiting to see whether or not the remote call was successful. If the receiving system does not become active within a certain amount of time, the call is scheduled to run in batch. The system logs the remote call request in the database tables ARFCS state and ARFCS data with all of its parameter values. You can display the log file using transaction SM58. Now, this transaction SM58 is used to monitor these TRFCs. TRFC is nothing but when data has to be sent from one system to another, the data is shipped between two SAP systems in form of TRFC. T stands for Transactional RFC. So in the source program, the call is triggered and it is sent through transaction ID, a TRFC, which has its own unique transaction ID to the receiving system. For any reason, if the receiving system is down also, there is no issue. So it piles up in the source system, and it waits there until the receiving system is up. If the receiving system is already present, then the TRFC is moved, is executed and sent to the receiving system. To store all this transactional RFCs information, we have two data, ARFCS state and ARFCS data tables, which has the data and the state of the transaction ID. So when you execute SM58, this is the initial screen. So here you can put the date, you can filter on username, the function module, the destination, because each system can be connected to n number of systems. So we have the destination also, and the status. Status means whether it's running or it's failed, whatever it is. So generally while daily monitoring, you put a star here, means like everything, you give the date, whatever date you want to monitor, and you execute it. Then the log file is displayed. See here you have this caller user ID, the function module, the target system, date and time, and some status text and the transaction ID. Here see, user is logged, please notify the person responsible. So here in this case, the correspond whatever function call in the target system it's trying to invoke, whatever it is, it has to do, there should be some user, right, to communicate from one system to another. So here SAP, that's an SAP user. So here it's saying like this user is logged, the user is logged in the target system. That's why this TRFC has failed. Red immediately you can see like it's failed. Okay, so then you have to check whatever problem is this and then rectify it, and there is an option to re-execute it again. Now all these TRFCs are generally piled up, okay, and we schedule a batch job in the source system, probably for every half an hour or 1 hour or whatever it is. So when all of them pile up, that batch job triggers, it executes all these piled transactional RFCs, and it executes them. Okay, say like if it's failed now, again that batch job runs for the next half an hour or 1 hour. It tries to re-execute it, so it does for a couple of times. Okay, so it keeps on like executing it until you delete this entry from here. Understood? So that's why like every day you have to check what these errors are. Okay, and then if you have rectified them, go and re-execute it. Or else if you think like it's sent through a new TRFC again and this failed TRFC is no longer required, then go ahead and delete it. Otherwise there will be the bad job running in every system to execute these transactional RFCs. Okay, so if it's like keep on failing continuously, if you have so many error ones, like next time it will run, it will try to execute, it will fail again. So entries, these two tables will increase unnecessarily. So that's why just monitor the failed ones. Okay, and if you see few TRFCs for a long time, if they are in running state also, then also there might be some issues, because data will instantly be shipped from one system to another. If you find them hanging over here for a reasonable amount of time, then investigate them, and especially the error ones are to be monitored every day and rectified. If they are no longer required, then we need to go and delete them also. You have an option like single one, you can select and delete, or you have an option as well where you can reorganize this entire error ones. Okay, so transactional RFC is nothing but it's this is how through a transactional RFC data is transferred between one SAP to another SAP system reliably. You understood, right? So we have to, during our daily monitoring, we have to even check these TRFCs, and that is done through T code SM58. Now the next one is QRFC, that is transactional RFC. This is queued RFC. The QRFC is an enhancement of the transactional RFC that also allows you to send and receive data in fixed call order. The QRFC is enhanced by an additional queuing mechanism which says the LUWs, logical units of work, to be sent or received in an outbound or inbound queue respectively. These LUWs are sent or transferred to the receiver application in the exact order in which they were saved. Now here also, whenever that batch job runs for periodically, so they will be executed in order only. Okay, but you manually users manually, what they do sometimes, without knowingly, they can execute this first and this next. Sometimes we can miss this, the order in which the data has to be passed from one system to the other. But in QRFCs, okay, so here what happens is that all the data which has to be moved from one system to the other system, it moves exactly once and in order. QRFC administration contains the following tasks in particular: specifying logon data for RFC destinations, register, deregister and exclude destinations for the outbound and inbound queue, monitor the outbound and inbound queue, activate, lock and delete queues. Now in QRFC administration, we need to take care of different things. So here data is sent. Once it is sent and received from the sender system, it goes into the outbound queue, and the receiver system, it comes into the inbound queue. Okay, understood? So here the data is sent exactly once and it's sent in order. Order is given more priority here. So if you have any data which has to be strictly sent in order, so then it is moved in form of a QRFC between two systems. So here we have to check the logon data for RFC destinations. RFC is nothing but a remote function call. Now one SAP system has to say like it has to get connected to n number of SAP systems. Then there is one T code known as SM59 where you maintain all these RFC destinations. Say we have two systems A, B, C and XYZ. So in ABC you have to configure an RFC destination for XYZ. Similarly in XYZ you have to configure an RFC destination for ABC. That's how two systems can communicate in SAP. If you want a communication between two systems, then in our T code SM59, okay, to one system you have. If it has to connect to n number of systems, then to those n number of systems you have to create RFC destinations. Okay. So in this QRFC and TRFC, that's what we see. We see the destination here. This is the target system. Okay. So there in the source system or whatever communicating systems, both senders and receivers, you have to create all these RFC destinations and ports for the logical systems for the other systems to which it has to communicate. So then here you can register, deregister and exclude destinations for outbound and inbound queues, monitor these queues, activate, lock and delete queues. So here in QRFC, data when the sender, it comes to the outbound queue, gets processed. In the receiver, it comes to the inbound queue. Okay, so we have both outbound queues and inbound queues for all the systems. Different transactions are available to you by executing these activities. SMQS, administrating the queue out scheduler, the outbound scheduler. SMQR, administrating the queue in scheduler, that is the inbound scheduler. SMQ1, the QRFC monitor for the outbound queue. SMQ2, the QRFC monitor for inbound queue. So here in QRFC administration we have 4 transactions. SMQS for monitoring the outbound scheduler, SMQR for monitoring the inbound scheduler, SMQ1 to monitor the outbound queue, QRFC outbound queue, and SMQ2 to monitor the QRFC monitor for inbound queue. We'll see what these are. See, this is the outbound queue. So outbound queue, what is the transaction? SMQ1. So once you execute out SMQ1 and you execute it, this is the initial screen. Okay, the client, the queue name, the queue destination, okay, or the waiting queues only. So client is important because data can be client dependent or client independent. Okay, so generally for all this transactions like product data, master data, data is more client dependent. So that's why I have to give the client here, queue name and queue destination, you can give star and you execute it, and this is the screen which is presented. So number of entries displayed are 430 and queues you have 4 here. Okay, see the queue name, the destination and the entries. Okay, this is how it works for an outbound queue. Similarly, inbound queue, you have client name, queue name. Okay, so you give star and execute it. Similarly, like outbound queue only, you will be displayed with all the entries. That is nothing but for the inbound queue. Okay, so you have to monitor these queues also. Okay, whenever there are so many entries piling up in this outbound or inbound queue, that means there is something like huge transfers between one system to the other, like loading or something. Okay, then you have to monitor those systems carefully, and if there is anything in error, then we need to correct it. Say like the RFC destinations are not configured properly, or say the user is logged or something, it can fail because of n number of reasons. The update has failed while this RFC is getting executed, or because there is some table space issue or something. Okay, so every day it's a good practice to monitor these queues, these outbound and inbound queues through transaction SMQ1 and SMQ2. Okay, just monitor the failed entries, try to rectify the error. If not, send it to the correct team. Okay, so once the error is rectified, you can reprocess the error once. Okay, and similarly you can monitor these queues to check what activity is happening in the system. Whenever like daily you're just finding a few below 500 entries, but today I'm seeing like some 5 lakh entries are there, then you have to check like any particular data loading or something is happening in the system or not, whatever it is. Okay, so these are very important transactions: SM58, SMQ1 and SMQ2. SM58, it's for transactional RFC. Okay, even this has to be monitored every day, and even these two, the error ones, especially in SM58, we have to take care about them. Okay, because if you leave the error ones, the job which runs to process this TRFCs, it keeps on reprocessing these error ones every time, and simply the data will be piled up in these two tables. So take care of the error ones and fix them and re-execute them, or if they are not required anymore, delete them. Okay, and similarly here, if you are finding any queue which is stuck for a long time, then also probably you need to analyze like why it's executing since such a long time. Similarly, in QRFC administration, we have 4 different transactions: SMQS, SMQR, SMQ1 and Q2. Okay, Q1, SMQ1 is to monitor the outbound queues, SMQ2 is to monitor the inbound queues. Here also you have to check the error ones or the long processing ones, or if there are huge number of entries, and take immediate action. Now coming to the administration transactions, SMQS and SMQR. This is about SMQR, the inbound queue scheduler. Okay, here you see the scheduler status is inactive. Okay, and you have different queue names. Okay, then the type, R stands for registered, the mode, the maximum runtime, the attempts and pause. So the inbound scheduler can be inactive. Okay, if it sees any entries in the inbound queue, then it will become active and it will process them. And whatever queues through which the data is sent, the queue has a name, right? So those queues have to be first registered here. Say like some queue somebody manually deregistered it, or because of some error it got deregistered, then that queue name, whatever you see it in inbound queue list, say like this one is registered now. Now I purposefully deregistered it, or due to some error it got deregistered itself. Okay, then the entries in these queues and inbound queue, when you check SMQ2, they'll not be processed, they'll simply be in waiting state. Okay, so that's what I'm telling. If you find any entries waiting for a long time, then you have to go to SMQR and check whether the queue is registered or not. And sometimes if somebody is explicitly deregistering any queue, see, these are the production issues which we have faced many times. Okay, sometimes somebody like purposefully they'll deregister that queue. Okay, then if while daily monitoring, if you find something deregistered, don't go and register it anytime by yourself. You have to check like is it like because of some purpose it has been deregistered. Okay, so these things, that's what, maybe they are testing something. Okay, so these are the administration transactions are generally like you have to check first, come to know like why something has been done, and then only action them. Okay, this is not this SMQR and SMQS are mainly the administration transactions. Okay, so before doing any changes to these transactions, please be very careful. If you want to register a queue, or if you want to deregister it, or if you want to create a new connection here, the queue name, whatever it is. Okay, if you find any abnormalities, or if you find something unusual in this, first try to find out like if somebody has done it purposefully, because I have seen many cases like that somebody has deregistered that queue. Okay, we'll be monitoring inbound queues, so many entries are piling up, we'll go and check SMQR, that queue will be deregistered, and we'll activate it. That's it. What, like they were doing some testing, so purposefully they have deregistered it. No, we went and registered it, so that will create a problem for them. Okay, so that's why be very careful and cautious before you delete any entry also in SM58 or Q1 or Q2. You check with the corresponding user or the team, make sure like it's not relevant or required in the system anymore, then only go and delete it. Otherwise data will be lost. If you see error ones, don't go and delete them anytime in these transactions. Okay, identify it, find out, if required reprocess it, or if you get a confirmation then only delete it. That's why if you do any deletions from these three transactions, it will cause data inconsistencies. Okay, so before deleting or activating or deactivating whatever you're doing, be very careful and cautious. Now this is SMQS, the outbound queue scheduler. So here we can see the scheduler status and the destinations. Here also they are registered. Okay, so right now they are inactive, but if some transfer is happening between those destinations, they will become active. So that's why the scheduler, if you see the scheduler status as inactive, don't worry, that's common, because like maybe there is no activity in these queues, it's into inactive status. But whenever there is some data waiting in the queues, the scheduler will get activated and it will process the information. Okay, and be very careful like while registering and deregistering these queues also. This is about SMQR and SMQS. See, here we'll have various options like registration to register the queue, registration without activation, without activating only registration, then deregistration. Okay, the QRFC monitor. Here you can see the QRFC monitor. Here you can see the QRFC and the TRFC monitor. Okay, and you'll have like the registration table. If you go here, you will see various options. Okay, so from there you can create a new destination here or delete. Say like you have created one queue name and it's no longer required, then probably you can go and delete it also. Okay, so this is all about SMQR and SMQS, the queue in and queue out, that is the inbound and outbound schedulers. So with this, we today in this video we have seen about these three transactions, that is SM58, SMQ1 and SMQ2. Okay, SMQR and SMQS. So all these transactions are used for monitoring the TRFCs, the transactional RFCs, or the QRFCs, the queued RFCs. So data is generally moved from one SAP system to another through a TRFC or a QRFC. The difference between a TRFC and a QRFC is like TRFC data is sent securely and reliably exactly once. However, in a QRFC it is exactly once in order. Order is given importance here. Okay, and these are the different transactions. Okay, 5 different transactions we have seen which are used to monitor and administer the TRFC or the QRFCs. Okay, then with this we wind up this video, and in a next video we'll again see a couple of transactions which are used in daily monitoring. Thank you.